more calculations. Okay, Hess's law of summation is just like when we did it with delta H values. You have to get this overall reaction from these pieces. So you need carbon as diamond on the left, which you already have. So that means this reaction we're going to keep exactly as it is. You need graphite on the right. So this reaction we're going to need to reverse. So when we reverse it, that gives us the CO2 gas on the left, the C graphite solid, and the O2 gas on the right. And when you reverse, you change the sign. Now I'm going to cross off this one since I reversed it, and we don't need that anymore. So O2 gas on the left and the right cancels. CO2 gas on the right and the left cancels. We have now diamond on the left, graphite on the right. We add these and we get -3 kilojoules, which tells us, since this is a negative delta G, that this is a spontaneous process. Now remember, spontaneous does not mean fast. Another calculation, we have this one. So we have Q, our reaction quotient, so products on the top. Our product is a pure liquid, so it's nothing. And then our reactants on the bottom. Okay. Now, let's see what our values for this are. 5 atm. Okay, so we're doing this in pressure. So instead of this, I should have the pressure of CO times the pressure of H2 squared. Remember, concentration and pressure, it was the same pattern. So we have 1/5 times 3 squared. Work this out, we get 0.022. Yep, 1 divided by 5 divided by 9. Or you can put it in the calculator and actually put the parentheses on the bottom. And it's going to give you the same thing. Just remember, you're always dividing by if you're on the bottom. All right, so there's our Q. Now, to get this, to get delta G at standard, delta G naught, we need to use the summation like we did earlier with data from Appendix 4. So I went and looked up the values from Appendix 4. So we have products minus reactants, just like we did right here in our first one. So our methanol is our product minus our reactants. We have CO, which is -137, and 2 hydrogens, which doesn't matter because it's 0. So we have -166 plus 137. So we have -29. And this is kilojoules per mole. All right, so now we can plug into the equation. So we have -29 kilojoules per mole plus 8.314. I should put the examples right under the thing. 8.3145 joules per mole Kelvin. Hope I'm not making you dizzy here. Times our temperature in Kelvin times the natural log of our 0.022, and it was actually 0.2 repeating, so since I'm putting it in the calculator, I can actually use that whole thing. All right, so I am going to take my 8.3145, multiply it by my 298, multiply it by the natural log of, I'm going to grab that to put it in there so that I'm not rounding. And so we get negative 9431. Here I have negative 29 kilojoules per mole plus, now let's check out the units on this. The natural log will have no units. So this is joules per mole. I can't add kilojoules and joules. So take my joules, convert it to kilojoules, and now I can add these. So I've got negative 29 plus negative 9.431. I've got a random decimal in there that I need to get rid of. There we go. Let's get a negative instead of a decimal. There we go. And negative 38. Okay. Now my 9431 that was in joules, I did this to get it to kilojoules.